Hi, ninth grade. This video is demonstrating how to solve Lindsey's scenario. So Lindsey is moving from Dallas, Texas to New York, but she's going to stop in St. Louis, Missouri on the way. And from Dallas to St. Louis, she will travel 600 miles at a bearing of 40 degrees. Then from St. Louis to New York, she will travel 950 miles at a bearing of 70 degrees. Draw a figure to represent Lindsey's journey. And how far north did she travel? How far east did she travel? And what is her return bearing from New York to Dallas? So let's start by getting a collection of our bearings. So first, from Dallas to St. Louis, and I'm going to use S for St. Louis and D for Dallas. That's 600 miles at a bearing of 40 degrees. So here's from Dallas to St. Louis, and that is at a bearing, so this is north, and this is a bearing of 40 degrees. So I'm just going to keep that over here as a reference, and I know that this distance is 600 miles. I'll label that. From here, we need to think about St. Louis to New York. So from St. Louis to New York, we know we're going northeast some way, and that is a bearing of 70 degrees. So draw your north from St. Louis, 70 degrees, and that distance was 950 miles. And again, this is from St. Louis to New York. Now this first question that we're going to answer, draw a diagram representing Lindsey's journey. We need to put these two bearings together. So start by where she started. And notice I'm giving myself about a half a hand space this way. I'm going to start down here at Dallas and think about your directions. North, south, east, west. Here's 0 degrees. Here's 90 degrees. Here's 180. And then 270 degrees over here. And again, that is 0 degrees north. Now, from Dallas, we need to draw this distance to St. Louis. And that's 600 miles. Drawing our distance north with our bearing of 40 degrees. Notice that it's just a little bit bigger than this one. But this is where we will do most of our work. And then lastly, from St. Louis to New York, drawing that vector north, but this distance is a little bit wider. 40 degrees is smaller than 70 degrees. So this is just a little bit wider. And this distance is 950. So I'm going to extend it out a little bit more. And notice that the north and the east directions are perpendicular. So they form a nice right angle. Now we need the north distance. So I'm going to call it N1 and N2. And then we also need the east distances. So I'll call this East 1 and East 2. So first we will find our north distance. Oh, that was a typo. That should be Lindsey. So calculating that north distance, we have two triangles to consider. 640 north 1 and north 2. Here's 950, and this angle was 70. And there's a right angle. So notice that both of these are the adjacent side. And so we are going to use the cosine of an angle, which is the adjacent over the hypotenuse. And this will help us solve for the north distances. Cosine of 40 equals n over 600. And cosine of 70 is equal to that north over 950. When we multiply both sides by this denominator, we get n1 equal to 600 times the cosine of 40 degrees. The other north distance is 950 times the cosine of 70 degrees. And then that total distance north is just adding those two together. And I will show you that calculation. So we would have 600 cosine 40, close parentheses, plus 950 cosine of 70. And I can just hit enter since I'm at my last measure. We get about 785 miles. Now let's look at the east distance. So now focusing on the east distance, we have two triangles again, but I'm going to label them slightly different. Here's the first one that we're trying to solve for that east distance. So our right angle, 40 degrees, and this is 600 miles. And then the other triangle is 70 degrees. Here's that east distance, 950 miles there. And now think about the relationship you have here. 70 degrees is across from this distance. Same with 40. So that is your opposite side. So we will use the sine ratio, which is the opposite, over the hypotenuse. So that means the sine of 40 is equal to the east distance divided by 600. And the sine of 70 is equal to the east distance divided by 950. And just like up here, to get those distances, multiply both sides by your denominator. And so the first east distance is 600 times the sine of 40. And the second distance is 950 times the sine of 70. And the total east distance is equal to the first distance plus the second, which is about, we have 600 sine 40, close parentheses because I'm doing another operation afterwards, 950 sine 70. And that is a bigger distance, and that is 1,278 miles. Okay, now what I would like to show you is where are those distances on our figure? Well, if we think about from Dallas, oh, and forgot to put the N here for New York. If we think about the distance from Dallas straight north and then east, we could find the direct distance from Dallas to New York. Say Lizzie took a flight or drove straight or flew straight from Dallas to New York. We could find that distance using these two lengths. The north distance is 785 miles. And then our east distance, that was the bigger one, 1,278 miles. A squared plus b squared equals c squared. You could easily find that distance. How could we use the Pythagorean theorem? Well, remember, east and north are perpendicular, form a right angle. But now, what if we wanted the return bearing? Notice this vertical line right here is the north line. So this is the north at 0 degrees. This angle right here, I'll call it theta. Theta is the return bearing from Dallas. Oh, I'm sorry. We need it. This would be the return from Dallas to New York. That's what this angle would be. But we need the return bearing from New York to Dallas. So we need this bearing right here. And what I want you to notice is that this north and this east distance, that's 90 degrees. So we have to do a little work to get this angle. I'm going to call it X. And then we would subtract 90 and X from 360 to get this remaining arc that will be our return bearing from New York to the straight line to Dallas. So let's use some trigonometry to find that angle. This is the triangle that we are solving. 1, 2, 7, 8, 7, 8, 5. Here's angle X that I referred to up there. When you look at this triangle independently from the figure, because there's a lot of stuff going on in that figure, notice you have the opposite and the adjacent. Tangent of X is the opposite over the adjacent. So that means tangent of X is equal to 785 divided by 1278. And that tells us x is equal to the tangent inverse. Remember, whenever we're trying to find angle measures, use the inverse ratio. 785 divide 1278. So second tan 785 divide 1278. About 32 degrees. So if this angle is 32 degrees, the return from New York to Dallas is 360, subtract 32, and subtract the 90. Which is about 238 degrees. I'm going to zoom out so you can see the full picture of the work. Thank you for watching this video.